Good morning, namaskar to all honorable guests on the dais and to all my friends in the auditorium. We have received at least 12 applications for the boiler engineers and managers, 9 numbers application from the boiler operator, and 3 numbers application from the industry who change in the boiler and boiler plant. First of all the applicants work hard to increase the safety of our plant and also to save the fuel cost. So they get the success. They work for the industry and for the nations. So congratulations to all of the participants. For their effort, we are giving a small award, but for this platform, but achievement is very valuable. As per talk wisdom, yes sir. And thank you to all the participants and the industry to take the opportunity to get the awards. Now I declare 3 categories, first number 3, first number 2 and first number, finally number 1. For best boiler user in manager and engineers, we got 12 applications. Out of 12, number 3rd is also Mr. Jitendra Patel, manager, Aarti Industries Limited, Vapi.
I would like to invite Mr. Mehul Vaidya to appreciate the awardee.
He has taken number of smoke drills in a plant and boilers, installed a furnace draft controller, and regular health checkup of the boiler and boiler plant for the safety of the boilers. On the second winner is Pragnesh Panchal, Deputy Manager, Deepak Nitrite Limited, Vadodara. He has improved a steam and fuel ratio, installed a fogging system in a coal heating plant for work safety and work environment, and CO2 achievement due to unburn reduction.
I would like to call Mr. Mehul Vaidya again to appreciate the awardee.
And number 1, from ONGC Hazira plant, Sri Karan Singh, Executive Engineer. Revamping and upgradation of the boiler, installation of suction damper modification, new installed valves and added new valves, saving in plant cost. Now in second category, boiler operator. 3rd number, Sri Bagu M. Naika, Deputy Technician, ONGC Hazira, Surat.
I would like to invite Shri B.H. Patel to appreciate the awardee of this category.
Second number, Kiran Bhai M. Parmar, boiler operator, Kiri Chemicals Industries, Vadodara. By installing oxygen analyzer, improves the combustion. And best operator, number 1 for this category, Sri Mahesh S. Patel, Executive Utility, Gujarat Fluorochemicals Limited, Panchmal. Providing on-off sprinkler systems in a coal yard, reduce dusting, and change in scrubber design from wet dry to wet. Now in third category, for change in design in boiler and boiler part and boiler plant. Number third, MS Barpatre, General Manager, ONGC Hazira Plant.
I would like to invite Shri Rohintan Engineer for the appreciation of awardee.
In this category, number 2, Neil Patel, Senior Executive, Godrej Industries Limited, Walia, Bharuch. Install a wet heat recovery compressor to improve the feed water temperature. And number 1, Sri Vipul D. Hirani, Manager, Fire Game Automatics Production Private Limited, Bharuch. Reduction in emission, fuel storage design, increase employment, and reduction of gas cost is an achievement.
Now, I would like to invite Mr.
Thanks, Saket, to select us and my team for the award function. Thank you.
Thank you so much, sir. Now, I would like to invite Mr. Jayesh Shah from Forbes Marshall to announce the Forbes Award. My bad, Mr. Prem Bhagwat.
Good morning to all of you, and thanks to the organizer. So as the Steamtech is 14 years old, we are also doing our part of it by encouraging all industries to participate into FM Encorn Award, that is a Forbes Marshall Encorn Award. And like every year, this year also we have a widespread participation from all industries like textiles, pharma, chemical, food and beverages. The fuel bill means the amount of, I would say the capital expenditure on the fuel is ranging from 3 crore to 100 crore. That's the range what the industries participated this year. And the savings potential which they have saved actually. So Mr. Vyas talked about the exchanging emails, but these are the people who have actually worked on the ground and saved the fuel. So big round of applause for them. So the savings potential, what they saved is in the range of 3 to 15%. So that's the range. And we are very happy to announce the winner. I would say their fuel bill was 8 crore and they could save 14% on that 8 crore, which is amounting to 1.1 crore. And again, this 1.1 crore fuel savings is not only on account of boiler, but they have worked for improving the boiler efficiency, thermic fluid efficiency, the process trapping, mainline trapping part, and more importantly, the entire heat recovery part from condensate and flash. So the winner is Sudarshan Textiles from Surat. On the account, they are not able to join over there here because of some emergency. So I would request Mr. Vimal Patel, who is our representative from Forbes Marshall Surat, to take this award on the honor of the customer and then hand over to them. And to do the honors, I would request Mr. Jainarayan Vyas, Mr. B.H. Patel, and Mr. Mehul Vaidya to please come and do the honors. So big round of applause for all who have participated. Can we get 2 minutes so that Vimal tells what actually customer has done? Thank you all. Would request all of you to participate with more zeal and more numbers next year also. Vimal, 1 minute. I would request Vimal to just share in 2 minutes what kind of joint efforts they have put with the customer so that everyone is aware how they could achieve the 14% savings. Maybe just in a brief, Vimal, you can just explain. Thank you.
The customer is Sudarshan Textile Private Limited. He is having a dyeing and a printing plant in Surat, having a fuel bill of 8 crores. They are spending on the boilers and thermic fluid. We have seen the total cultural change in the customer also, because implementation of this type of technology, which demands the cultural change from customer also and from ourselves also. So they have implemented boiler automation system on the boiler, thermic fluid automation system on the thermic fluid heater, and the overall steam system and condensate system they have improved from the trapping uptime percentage improvement, then the condensate recovery factor improvement, flash steam recovery improvement, and the totally is the feed water temperature improvement. So by doing all these activities, customer has improved the feed water temperature, and by doing this activity, they are saving the almost 13% of the existing fuel bill. So we are happy to share the success story of Sudarshan Textile. Now they are engaging with us with the sustenance part of this saving part through digital service. So we are talking about the customer with the digital service we are giving to customer for the sustenance of this savings. So thank you.
Now, I would like to invite Shri Rohinton Engineer for the vote of thanks.
Good morning to you all. So I stand before you between the tea and the vote of thanks. So I'll take just a few minutes of yours now. Mr. Jainarayan Vyas, the man with the mission behind this seminar, Mr. B.H. Patel, Director of Boilers, Gujarat, Mr. Mehul Vaidya from Forbes Marshall, Mr. Dharmendra Joshi and Mr. Pandya, and of course Team Saket, present here today. I also wish to thank Mr. Gajjar, Mr. H.B. Panchal, Mr. Joshi, Mr. Kacha, Mr. D.R. Mistry, former Director of Boilers, and present Deputy Directors and Assistant Directors Boilers present here today. I also thank various chairmen and speakers of this technical session today. Fellow delegates, members of the press, friends, namaskar and thank you for all for being with us today. A very good morning to you, and I have the pleasant duty to perform the vote of thanks. First of all, on behalf of Saket Projects, we are very thankful to you all for being present this morning for this technical seminar, Steamtech, the 14th National Conference on Boiler and Steam Systems, Steamtech 23. We thank you for spending a valuable day with us, and we hope this seminar would be a thought-provoking and will offer various solutions to our day-to-day operational problems. In this seminar, emphasis has been laid on various things on improving boiler efficiency, safeties, pollution environment, and things like that. And of course, we have a very good addition of green hydrogen as a possible fuel replacement. Here, I would be very happy to state that my company IBL has already run 5 boilers on green hydrogen. And of course, some of them are on also from the process hydrogen that is available from the industry. And a few of them are in Gujarat itself. Also, it is important to note that the government of India is promoting hydrogen in a big way. There's a PIL scheme for manufacturers who can manufacture hydrogen plants. And that's going to be very beneficial to most industries. Since the past 1.5 years, my company has also put up a small hydrogen plant of 1 meter cube per hour. And we use that hydrogen for in the stress-link furnace and also for gas cutting. And it's green hydrogen because it comes from our solar plant. So it's very beneficial and it improves the quality of cutting and also the heating. So green hydrogen is going to be a major game changer for tomorrow. Also, we need to note that by, I think, next a year or a year and a half, green steel will have to be produced through green hydrogen. The European Union has already put in a carbon tax on steel produced from conventional resources. So steel is going to become cheaper, luckily, because plants that do not go to green hydrogen will be making steel for the Indian market only. So this is going to be a game changer. Green hydrogen is going to be a game changer. Of course, ethanol also is a very important thing. And in fact, the reason why the boiler industry is so busy today is because of ethanol. My company is, I think, doing about 25 units of power generation plants for the ethanol plants today. And they're coming up like mushrooms. Anywhere you go in India, you see there is ethanol plants coming in. And it's not that the government is also researching a lot in that. And today we have started producing rice, which has a higher starch percentage, specifically for ethanol plants. So that's also a game changer, because if you want more ethanol, you require higher starch percentage. So the government has already started issuing those seeds wherein you have a higher starch percentage. And like areas like Bihar and all that, where this rice was not a very costly commodity, has suddenly become very excellent commodity, and a lot of plants are coming up in those areas also. Gujarat, unfortunately, has not been able to do much in ethanol. Of course, 3-4 plants are coming in because we do not have that much of extra land available for further cultivation of rice. But all the broke that we have got is already going to be converted into ethanol in Gujarat also. So coming back to the vote of thanks, Steamtech is a premier technical seminar organized by Saket, wherein a major discussions are held on various subjects on national importance relevant to today's industry's need. Steamtech over the years has added various activities, and today we saw the award presentation. And that's an opportunity to all engineers concerned, industries concerned, because an award is an appreciation for his efforts put in. With the introduction of awards now being made an annual feature by Saket, it's a benchmarking for industries for innovation, efficiency, and safety also. Our Honorable Prime Minister has laid emphasis on the dependence on supply of energy, and as Mr. Jainarayan has also mentioned, that if we want to become a 5 trillion economy, energy is going to multiply not by 30%, but might be by 50%. So energy demands are going to go up, and the industry needs to be looking at it. And when we talk about energy, we are talking about electricity, fuel, and various things. Also, with our per capita income going up, our food bills are going to go up, our people are going to eat better and better quality of foods, more processed foods. So that way also a lot of energy will be required. In fact, energy in many ways is a primary input which fuels the economic growth of any country. With today's high cost of fossil fuels, oil and coal, today's seminar will give us further insight in this post-COVID scenario. An inseparable part of the energy scene is the environment aspect related to the production of power and steam, which today is predominantly to the burning of fossil fuels. The penalties we pay is to load the life-giving environment of like air, water, and soil with pollutants. And we are seeing the weather change. If you see the weather change in this monsoon, it is very startling. And amount of floods that we are receiving is all, I think, due to weather change. In short, energy conserved is energy produced. So lowering of energy consumption will automatically lead to a better environment. Here we are today also thankful to our various sponsors who have been kind enough and very gracious with Saket. We are thankful to the management of JB Auditorium Ahmedabad, who have given this lovely air-conditioned hall very comfortable for all of us. I hope the press is present today and they give us a good coverage for this program. We thank the police and other officials of Ahmedabad for their consideration and help. If you have committed any protocol, please forgive us, pardon us. Thank you. Jai Hind.
Thank you so much, sir. We are running about 15 minutes late on our schedule, so everyone is required to be back in the hall immediately after tea coffee. We have a short refreshment break and we'll start back at sharp 11:40. Hello. 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 Phone on silent mode so we can carry out our session smoothly. Without a further ado, let's get started our very first business session that is based on the theme of new approaches in boiler system design and manufacturing. Invite our dignitaries on the stage one by one. Mr. H.B. Gajjar, please come on the stage. And along with him, I would like to invite Mr. Chirag Panchal to welcome him with the memento and bouquet. Shri Jignesh Tandil, Vice President Sales and Marketing, Industrial Boilers Limited, Vapi. I would like to invite Mr. Rakesh Naria to welcome him with the memento and bouquet. Shri Deepak Chandarana. I would like to invite Mr. Anas Sheikh to welcome him with the memento and bouquet. Shri Bipul Paul. Along with him, I would like to invite Devendra Acharya to welcome him. Shri Karan Singh, Shri Karan Singh, I would like to invite Mr. Jayesh Joshi to welcome him with the memento and bouquet. Before a more detailed explanation, I invite Mr. H.B. Gajjar for the introductory remarks. Mr. H.B. Gajjar.
Good afternoon. Now, this is the opening for the first session. We are running late. Sorry to say, we are running late somewhat, 15 minutes, 20 minutes. So I request all the dignitaries on the dais to give short time to express themselves. So we can reach or we can finish our closing session by 1 o'clock. Okay. Now, Mr. Atul Shah, unfortunately, is not present. So I have to attend this session. First of all, I request Mr. Jignal Tandel, Industrial Boiler Vapi, to give this speech. નથી હવે કહી દઈશું શાંતિથી આપો જ પડે ટાઈમ દર વખત આ જ પ્રોબ્લેમ હોય છે કંઈ કરવાની જરૂર નથી.
Namaste. Am I audible? Yes. So, good morning to everybody, my friends, members on the dais, dignitaries. It's a privilege to be here, and we are thankful to Steamtech for allowing us to present ourselves before this wonderful audience. So, getting on quickly, not wasting much of your time, I'll get on to the topic. So, basically, today I'll be presenting on cogeneration. Cogeneration for the energy managers who are all over here. So, let's start on with the topic. So, here you see this man. ये जो बंदा है वो परेशान है. Why is he worried? The oil cost, the fuel cost is going up. Fuel cost is going up. Margins are coming down. तो कैसे manage करना है? How am I going to manage the show? So he'll have to plan strategies how he's going to cut the cost. तो cost cutting है. You have sustainability, you have to go with the environment. So how all this combined, how he's going to manage? So you have to find out ways. Ways में क्या है? So what I'm going to talk about today is, one of the ways is cogeneration. So what is this cogeneration? As the word goes, it defines two separate generations coexisting at the same time. तो जैसे हम steam generate करते हैं, we use it for a process for heating applications. Along with this, if we generate something else, so in this case it is power. तो अगर ये दो चीज़ साथ में होती है तो it is cogeneration. Okay, so like it is, steam is the basic requirement of the process industry, and we can co-generate by adding in, say, 5 to 20% of your fuel, and then we can generate the premium energy, that is power. So power is very premium because it is very costly. To explain this, see, if you see 4,000 kilocalorie of coal, जो आज की तारीख में 8 रुपये है, अभी post COVID it had gone up to 16 rupees, 15 rupees, 16 rupees. Everybody experienced. कई plants, many power plants which were running on condensing, तो काफ़ी लोगों को पार्शियल शटडाउन करना पड़ा था because the cost of generation had gone up so high. Coal had gone up, the gas prices have gone up to 65 rupees a meter cube. So in that cases it was very difficult for the industry to sustain. तो उस समय में वो realize हुआ कि what if we had something to back up. And those times, you know, people had, many of them had cogeneration systems on various applications. So they were able to sustain that shock. So 4,000, explaining, 4,000 kilocalorie of coal cost you rupees 8, कई जगह पे 9 रुपये भी होती. You have biomass in the similar range. And 4,000 kilocalorie of electricity cost 39 rupees. So electricity is very premium. So if you can generate electricity at a minimum cost, that will be of great advantage to us. It is a misnomer that energy is being produced. Cogeneration does not produce energy. It merely converts the heat energy into electrical energy. So because it converts this heat into electricity, the efficiency, energy efficiency of the cycle is very high in cogeneration, and that's why you are able to get very fast paybacks. Now, what are the needs and why we have to go in for cogeneration? Basically, one most important thing is the grid cost has gone up. There is uncertain and unreliable power availability. Heavy demand charges are there. There is load shedding at many places. Heavy running cost of DG sets, and very important, there is very heavy competition, and to have a cutting edge, we have to go in for certain systems which will give us a competitive edge. And one most important, to conserve our environment. So what are the essential requirements for you to go in for cogeneration? So one important thing is, what is the process steam requirement? Process के लिए steam pressure का क्या requirement है? वो determine करता है कि आप cogeneration कर सकते हो कि नहीं कर सकते हो या किस level पे कर सकते हो. Second is, what is the demand of steam? The higher the demand, the lower are the ROI, the lower are the paybacks. Then what is the power requirement of your plant? So that will depend, that will define what kind of cogeneration we can go in. ये एक सिंपल डायग्राम है. अभी बेसिकली हम क्या करते हैं, तो प्रोसेस के लिए स्टीम हम जनरेट करते हैं 10 बार, 15 बार, that is saturated steam. We take it through a pressure reducing station, PRV से लेके जाते हैं, ठीक है, और लो प्रेशर स्टीम हम प्रोसेस में यूज़ करते हैं. In this case, what we do is, we generate steam at a slightly higher pressure or at the same pressure, and instead of passing it through the PRV, we take it through a turbine. In the turbine, your kinetic energy is converted to electrical energy, and that is how you cogenerate. टर्बाइन सिलेक्शन के फैक्टर्स मैंने अभी आपसे डिस्कस किए अगली स्लाइड में. Now various types of the cogeneration and the power generation systems. जो पहला आता है, first one is the microgen. Microgen में क्या होता है? So basically we have an existing installation. We have a process boiler. Okay, वो process boiler में से हम we are taking steam through a PRV, and we are using this saturated steam in the process. In this case, instead of passing it through the PRV, we take it through a turbine. एक छोटा turbine install करते हैं, and whatever is the byproduct, हम पावर जनरेट करता है. अभी ये पावर रेंजेस फ्रॉम से 50 किलोवाट and it can go up to 1 megawatt depending on the quantum and the pressure of steam available. So this system we call it the micro cogen. उससे थोड़ा हाई लेवल का जो आता है तो that is the cogen. That in the cogen we generate steam at a slightly higher pressure and with some superheat. In that case we generate higher power, amount of power is higher as compared to a microgen turbine. So both these cases are cogeneration cases. Then we have one more case, that is the captive generation. तो captive generation में क्या होता है, we have process steam requirements and we have power requirements also. तो suppose we have a certain power requirement but our steam load does not match that power requirement. So in that case what we do is we go in for a extraction condensing type system. तो extraction में क्या होता है, whatever is your process requirement, वो process requirement के हिसाब से आपकी turbine power generate करती है. Now this power is not sufficient to fulfill your complete plant needs. So the balance of plant is generated from the condensing side. So this case we call it the captive generation. इसमें एक्सट्रैक्शन होता है और कंडेंसिंग दोनों होता है. एक्सट्रैक्शन की जो स्टीम होती है दैट इज़ अ पार्ट ऑफ कोजेन एंड दैट इज़ वेरी चीप पावर. मतलब वो इज़ दैट इज़ अ वेरी एफिशिएंट सिस्टम. दैट इज़ वाई योर पावर इज़ चीप. जितना आपका कंडेंसिंग ज़्यादा होगा आपकी पावर साइकिल का कॉस्ट बढ़ेगा. सो यू कीप अ मिनिमम ऑफ कंडेंसिंग दैट विल गिव यू गुड पे बैक्स. और जो फाइनल चौथा सिस्टम है वो 100% पावर जनरेशन है. 100% पावर जनरेशन में क्या होता है, आपकी प्रोसेस में स्टीम रिक्वायरमेंट्स नहीं है, यू ओनली जनरेट पावर थ्रू द कंडेंसिंग मोड फॉर योर पावर प्लांट. इस केस में यू हैव टू हैव, आपका फ्यूल सस्ता होना चाहिए. यू हैव टू हैव वेरी लो कॉस्ट रिसोर्स ऑफ फ्यूल. अच्छा, तो अभी आई विल एक्सप्लेन यू सम सिनारियोज वेयर यू विल बी एबल टू अंडरस्टैंड के स्टीम के कंडीशंस, मतलब इनलेट कंडीशंस, आउटलेट कंडीशंस पे पावर जनरेशन कैसे वेरी करता है. सो दिस केस इज़ हाउ दी बैक प्रेशर, मतलब आपका प्रोसेस का जो प्रेशर रिक्वायरमेंट है वो अगर वेरी करता है तो आपके पावर आउटपुट कैसे वेरी करते हैं. लाइक फर्स्ट एग्जांपल इज़ कि आई हैव अ प्रोसेस स्टीम रिक्वायरमेंट ऑफ 3 kg. तो मैंने टर्बाइन का बैक प्रेशर 3 kg रखा है. माई इनलेट स्टीम कंडीशंस आर द फ्लो इज 10 ton, द प्रेशर इज 33 kg per cm square and the temperature is 350 degrees centigrade for all the 3 cases. In this case I am able, at 3 kg back pressure I am able to generate 600 kilowatt. This is just an example. ठीक है. अब मैं अगर मेरा बैक प्रेशर 1 kg से बढ़ाता हूँ, इफ़ आई इंक्रीज माई बैक प्रेशर फॉर द प्रोसेस बाय 1 kg, तो व्हाट इज़ द रिडक्शन इन प्रेशर पावर, तो इट गोज़ डाउन बाय 60 किलोवाट. अभी अगर मैंने बैक प्रेशर मेरा 4 के बजाय 5 kg सेट किया, अब मेरे प्रोसेस की रिक्वायरमेंट है, हायर प्रेशर है, हायर टेम्परेचर रिक्वायरमेंट है, तो आई सेट इट फॉर 5 kg. तो मेरा पावर है, माई पावर आउटपुट पावर हैज़ कम डाउन टू 500 किलोवाट. सो आप देख रहे हो कि फ्रॉम 3 kg एज आई गो टू 5 kg माई पावर आउटपुट हैज़ गॉन डाउन बाई 100 किलोवाट. तो 100 किलोवाट इज़ अ ह्यूज अमाउंट ऑफ पावर. तो कहने का मतलब है कि अगर आपकी प्रोसेस रिक्वायरमेंट अगर कम प्रेशर में चलती है तो वो कम प्रेशर पे ही चलाओ. डोंट गो इन फॉर एक्सेस प्रेशर्स, अदरवाइज इट विल, आपकी जो एफिशिएंसी साइकिल है पावर की वो कम हो जाएगी एंड योर पेबैक्स विल गो अप. अब सेम केस अनदर सिनारियो के इनपुट कंडीशंस चेंज होते हैं, कि इनलेट कंडीशंस आर चेंजिंग. सो इन फर्स्ट केस आई हैव inlet pressure of 9 kg, 250 degrees, flow is the same. Second case I have 21 kg inlet, 330 degree, and third case I have 33 kg, 350 degree. बैक प्रेशर्स रिमेन द सेम एट 3 kg. तो ये केस में भी पावर का आउटपुट चेंज होगा. सो फर्स्ट केस में वी हैव 145 किलोवाट, सेकेंड केस वी हैव 300 किलोवाट, थर्ड केस इट इज़ 340 किलोवाट. सो जैसे बैक प्रेशर बैक प्रेशर में क्या थंब रूल है कि यू हैव टू कीप इट डाउन टू अ मिनिमम. इनलेट प्रेशर में यू हैव टू कीप इट टू अप टू अ मैक्सिमम. तो इनलेट पे जितना आपका हायर प्रेशर होगा उतना आपका आउटपुट बढ़ेगा. बैक प्रेशर आपका जितना लो होगा उतना आपका आउटपुट बढ़ेगा. ये सेम केस है विद इनलेट स्टीम कंडीशंस वेरिंग. जैसे जैसे आपका इनलेट प्रेशर एंड टेम्परेचर्स बढ़ता है योर पावर आउटपुट गोज अप. So as a thumb rule, use lowest possible back pressure. It saves you on installation as well as fuel. आपका installation cost भी कम होता है क्योंकि आप सिस्टम को डिज़ाइन करते हो लो प्रेशर्स पे. तो बेसिकली योर प्रोजेक्ट कॉस्ट ऑल्सो कम्स डाउन एंड योर पे बैक्स ऑल्सो गोज अप. सेम वे आप अगर 1 kg बैक प्रेशर कम करते हो या बढ़ाते हो तो आपको इनलेट पे 6 kg बढ़ाना पड़ेगा सेम आउटपुट लाने के लिए. सो दिस इज द डिफरेंस. सो एट IBL वी डू बॉयलर्स एज वेल एज टर्बाइंस. हमारी बॉयलर मैन्युफैक्चरिंग फैसिलिटीज़, वी हैव 3 बॉयलर मैन्युफैक्चरिंग फैसिलिटीज़ एट वापी and 2 turbine manufacturing facilities. One is at Noida and one is at Port. At Noida we do up to 5 megawatts. At Port we do up to 50 megawatts. So what are the advantages of going in for a package cogen supplier? So first is you have 1 point source of supply. You have a proper integration of the process and the system. Means we are able to guide you better कि भाई आपका प्रोसेस का रिक्वायरमेंट ऐसा है तो यू कैन डिटरमाइन योर इनलेट कंडीशंस, योर आउटलेट कंडीशंस टू गेट द ऑप्टिमम आउटपुट्स. सो इट बिकम्स अ 1 point गारंटी. बॉयलर और टर्बाइन का दोनों का एक गारंटी है. ठीक है. सिस्टम डिज़ाइनिंग, पाइपिंग डिज़ाइनिंग में हमारा सपोर्ट होता है. सो इट्स दीज आर दी एडवांटेजेस. नाउ आई विल डिस्कस सम ऑफ द केस स्टडीज़. आपको केस स्टडीज़ थोड़े दिखाता हूँ. तो द फर्स्ट केस स्टडी इज़ ऑफ अ प्रोसेस हाउस इन सूरत. It's by the name of Aishwarya Prince, where in 2008 we installed a 18-ton boiler, a 35 kg, 18-ton 35 kg, 350 degrees, with a 1.3 megawatt back pressure turbine, 100% back pressure. The turbine produced on an average of 22,000 units at a steam load of 336,000 kg per day. The total demand जो है प्लांट का वो 40,000 यूनिट्स है. तो more than 50% of the units were generated from this co-generation plant. Back pressure system का 3.5 kg requirement है. And the payback period for this complete plant was less than 2 years. This plant was in operation in 2008. After this, in 2014, in the same plant, we upgraded. उनका प्रोसेस का स्टीप रिक्वायरमेंट्स बढ़े, पावर रिक्वायरमेंट्स भी बढ़े. सो दे इंस्टॉल्ड अ 32 ton boiler at 67 kg, 480 degrees, 490 degrees, along with a 2.4 megawatt back pressure. Turbine produced 46,000 units on an average per day at a steam load of 420 tons per day. उनका इलेक्ट्रिकल डिमांड भी बढ़ा था. It was around 56,000 units a day. This time they were able to generate more than 60% of their power requirement through this turbine, because our inlet pressures and temperatures are higher in this case. Earlier case it was 35 kg, 380 degrees. In this case we went in for 67 kg, 490 degrees. Back pressure same है 3.5. So with this they were able to meet more than 60% of their power demands. Now this this installation is in operation since the last 9 years. So payback तो 2 साल में आ ही गया. Now they are reaping the savings. One more installation we had in a kraft paper mill. एक 300 टन का kraft paper mill है, where they have a 25 ton 45 kg boiler which operates on coal. Now this this turbine, this plant generates 4,000 units of power a day on steam load of 500 tons per day, and the back pressure for this kraft paper unit is 4 kg. So this unit saves about 1,76,800 rupees a day. Okay. And this plant is in operations in the last 10 years. तो 10 साल में वो more than 50 crores का saving हुआ है इनको. This is one chemical unit by the name of Atul Limited. Here they have a 35 ton 65 kg boiler. It runs on coal, and we have installed a back pressure turbine. In this case the back pressure is a slightly higher. ये 8 kg की इनकी प्रोसेस रिक्वायरमेंट्स है. ठीक है. वो जो पुराने केसेस थे टेक्सटाइल मिल, नॉर्मली टेक्सटाइल मिल्स जो होते हैं प्रोसेस यूनिट्स होते हैं उसमें स्टीम रिक्वायरमेंट्स टेम्परेचर रिक्वायरमेंट्स आर लोअर. उस वजह से दे आर एबल टू मेंटेन अ लोअर बैक प्रेशर 3.5 kg. इवन क्राफ्ट पेपर मिल्स जो होते हैं उसमें भी जो टेम्परेचर रिक्वायरमेंट्स होती है वो लोअर रहती है. इसमें उस केस में हम 4 kg तक प्रेशर रखते हैं. बट दिस इज़ अ केमिकल यूनिट विच हैज़ हायर बैक प्रेशर रिक्वायरमेंट्स. तो यहाँ पे उनका 8 kg का बैक प्रेशर रिक्वायरमेंट है, and they were able to generate this power at unit cost of 4 rupees 58 paise. तो ये केस में भी the saving per day is 2,35,000 per day, and this plant is also in operation since the last 2 years. One very typical example, this is a deaerator application. डीएरेटर का जो स्टीम एप्लीकेशन होता है, आप पावर प्लांट्स में जब देखते हो तो आपके पावर प्लांट्स 10 मेगावाट 20 मेगावाट पावर प्लांट्स होते हैं, 30 मेगावाट के पावर प्लांट्स होते हैं. तो उस केस में क्या होता है कि आपके डीएरेटर की स्टीम रिक्वायरमेंट्स भी काफ़ी हाई होती है. इट वेरीज फ्रॉम से 60 टन से लेके 15 टन तक की डीएरेटर की स्टीम रिक्वायरमेंट्स होती है. अभी ये स्टीम आप क्या करते हो, यू टेक इट थ्रू अ ब्लीड. जो टर्बाइन का ब्लीड होता है वहाँ से आप लेते हो या उसके एक्सट्रैक्शन से लेते हो, एंड यू पास इट थ्रू अ PRS एंड यूज़ इट इन द डीएरेटर. तो डीएरेटर में जो प्रेशर रिक्वायरमेंट्स होते हैं वो लो होते हैं, 1-1.5 डिपेंडिंग ऑन द टेम्परेचर रिक्वायरमेंट्स. तो इस केस में हमने क्या किया कि जो आउटलेट था टर्बाइन का एग्जॉस्ट, इट वाज अराउंड 9.5 tons ऑफ स्टीम फॉर द डीएरेटर एट 7.5 kg 300 डिग्री सेंटीग्रेड. इसमें हमने क्या किया, जो टर्बाइन में है वो हमने बैक प्रेशर रखा 3.5 kg, एंड वी वर एबल टू जनरेट अराउंड 6,000 यूनिट्स अ डे. ओके, फॉर एन एग्जिस्टिंग इंस्टॉलेशन ये है. तो ईयर ऑल्सो दे आर सेविंग अबाउट 36,000 रुपीज़ अ डे इतने छोटे एप्लीकेशन में. देन वी हैव वन मोर केस स्टडी ऑफ अ पेस्टिसाइड. ये केमिकल यूनिट है बाय द नेम ऑफ हाइकल, where we have a biomass based boiler. ये 14 टन 45 kg 430 डिग्री का बॉयलर है. This unit generates about 29,000 units a day on an average steam load of 330 tons per day. The back pressure in the system is maintained at 4 kg. इनका जो पावर कॉस्ट आ रहा है वो 3 rupees 61 paise per unit. So they are also saving about 1,27,000 rupees per day. Sorry, ये figure wrong है. This plant is in operation since the last 8 years. One more typical example we have. ये case है, there is one company by the name of Ganesh Polychem. where it's a very typical example. कि ये केस में कैसा है, ये they have a common boiler and this boiler supplies steam to 2 different units. मतलब ये गणेश पॉलीकेम ये खुद के यूनिट में भी steam use करता है and it is using steam at 2 of its other sister concern units which are nearby. So the boiler is installed at 1 unit supplying steam to 3 units. Okay. Now for power what we have done, for power we have installed 3 turbines. One is at the unit where the boiler is installed. Second and third are the other 2 units where they are supplying steam. So 5 minutes. So I'll quickly run through, but this is a very typical example where basically what is the scenario is that you can sell steam, but you cannot sell power. So what we did is, whatever the steam requirements of the other 2 units, we installed a turbine at that location itself. So वहाँ पे steam गया higher pressure पे, they generated steam at back pressure at that unit itself, and power was consumed at that unit. So that way this unit are also in operation since the last 9 years. ये Ganesh Polychem is a unit of Aarti Industries. So we have a few people who have taken awards for this. Now quickly running through the models of turbines what we make. So this is a smaller turbine, a single stage turbine है. इसको हम PRT कहते हैं. ये 3000 RPM पे चलती है. It is without a gearbox. ठीक है, और ये इतनी सिंपल सिस्टम है. It operates for मिनिमम स्टीम फ्लो. आप 4 टन की स्टीम फ्लो होगी तो भी इट विल गिव यू पावर. ठीक है, और ये ग्रिड सिंक्रोनाइज भी होती है. इट हैज़ अ इनबिल्ट PLC इन दिस. सो वेरी सिंपल. और आप इसके बैक प्रेशर को कंट्रोल कर सकते हो 2 kg, 3 kg, 4 kg, वॉट एवर इज़ द रिक्वायरमेंट. सो वी कॉल दिस अ PRT बिकॉज ये PRS के बाईपास पे लगती है. देन देर आर अदर मॉडल्स. ये SS मॉडल है जिसमें हायर RPM पे चलती है. इट हैज़ अ गियर बॉक्स टू इट. देन वी हैव द BT4 मॉडल जो हायर प्रेशर और हायर टेम्परेचर पर, बट इज़ अ सिंगल स्टेज Curtis turbine. Then we have the multi-stage turbines which operates at higher pressures and temperatures. This is the condensing turbine. Condensing turbine अभी ये range में it's not viable at today's time. Then we have this reaction turbine. ये reaction turbine जो होती है वो basically it's a bigger frame. इसमें जो नॉर्मल जो इम्पल्स टर्बाइंस आती है उसमें स्टेजेस कम होते हैं. दे हैव 5 स्टेजेस, 7 स्टेजेस, 9. दिस टर्बाइन हैज़ स्टेजेस अप टू 19 और 19 स्टेजेस तक होती है. मतलब इट्स अ वेरी बिग टर्बाइन. सो इसमें जो रिकवरीज होती है, जो एफिशिएंसीज होती है वो बहुत हाई होती है. एंड दिस टर्बाइन वी मेक अप टू 50 megawatts. Recently we supplied this 4 units of 2 of 20 megawatts and 2 of 6 megawatts to Senegal. They are under installation. Okay. These are the other models. I am just quickly running through. Now just some ballpark figures of how much the power costs. So through back pressure it ranges between 1.6 rupees to 4.5 rupees per unit. Through condensing it is purely on fuel cost dependent and it will range from 6 rupees to 10 rupees depending on the cost of fuel. और एक्सट्रैक्शन कंडेंसिंग में भी जो आपका एक्सट्रैक्शन और कंडेंसिंग का रेशियो होगा उसके ऊपर वो 4 से 8 रुपए के बीच में आपको पड़ेगी. तो सक्सेसफुल एप्लीकेशंस है इसमें पेपर, टेक्सटाइल, डिस्टिलरीज, राइस, फूड एंड ऑल अदर यूनिट्स आर प्रेजेंस वर्ल्ड ओवर. थैंक यू.
I request you all again, please keep your phone silent mode so that the conference carried out smoothly.
I invite Mr. Deepak Chandarana from TCR Advanced Engineering for his views.
Respected participants, dignitaries, we are thankful to Saket Projects Private Limited for providing us the opportunity and honoring us to be a part of this big forum, a renowned forum, celebrated it annually. Basically, before I go to main subject of asset integrity, let me to say a few rather eye-opener words told by our inaugural session, Dr. Jainarana Vyasa. He said that we use 3 times more energy than Japan to generate 1 unit. He said we use 1.5 times more energy to generate 1 unit. So at present we are equal to or less than 3 trillion economy, and we are planning for, we are going towards 5 trillion economy in 2035. And for this we need energy. It's a very likely said. It is a really eye-opening. So energy at the same time, and when we are using much higher energy with the less efficiency. So now with the challenging scenario in today's era, asset integrity is of the prime importance, because when we are using more energy, we have to have reliable operations of our boilers and steam equipments. So, yeah, actually we rather propose for audit. Basically, as we do the energy audit, we rather propose for the boiler mechanical integrity, corrosion metallurgy, and process interference audit, by virtue of which we can take proactive actions. So we all know that power generating industries are facing a lot of problem of the cyclic loading because of renewable energy penetration. And as O&M practices in existent neglect consideration of extreme and rare events. Of course, in my input from the power sector expert, strategic advisor and experienced manager, narrowly focused on adequately address to the fundamental issues of the asset and system in constantly changing and unpredictable RES penetration. So here I would reiterate that, to rather, it's a time of an hour to integrate knowledge of process parameters coincided with the O&M philosophy, to proactively target the cause of potential damage mechanisms, causing subsequent degradation of the material. Because this is now a challenge, and it's a question of worry, because cyclic loading, ramping up, ramping down, frequent shutdowns, frequent startups of conventional generations has become now practice. So in order to do that, we rather propose audit. And we have more than 2,000 failure investigation studies of boiler itself. Totally 8,000 plus failure investigation we did in all the energy sector, petrochemical, chemical, gas, oil, fertilizer, etc. So we have a backup of exhaustive repository. So we have a lot of experience about how does it has occurred. So taking the cognization of the subject, the prominent speakers, right, they spoke many things about Mr. Rahul Vaidya, Mr. Rohit, an engineer. They talked about what's the market trend, what is the potential, and what is the scenario tomorrow, and how we have to be rather cautious about asset integrity. First of all, let me to say that asset integrity, as rightly said by Mr. Vaidya, that hydrogen would be the future. Then we have to take care of the safety, and safety comes with the asset integrity. So in that condition, this brochure itself says that boiler market in India is growing at compound annual generation rate of 24.53. So we know today's installed capacity of the India is 418 gigawatt. And still the coal or conventional fuel is the leader in contributing the total energy demand of India, and followed by the renewable source. So what we can do is the novel approach to asset management through the high-level risk-informed and decision-making framework, delivering overall risk ranking of asset, and as a result of assessment, inspection strategies can be formulated. What we say that, we do the remaining life assessment. So we should not consider it as a compulsory. It's a opportunity. So as and when we go for RLA of boiler, it's a mandatory as per Indian boiler regulations. So rather to consider it as a mandatory, one should consider it as an opportunity. Though now our concerns, boiler and associated systems goes under different mode of damage, either suddenly or gradually. There are total 36 damage mechanisms in the boiler which are responsible to lead the failure. Now we know that non-damage mechanism associated with the operating condition and metallurgy involved specific to the component or system are well established in literature and ASM. Now focus on changing operating scenario. That is what I talked, that focusing on changing energy scenario, right? If you look at the net energy arise of renewable penetration into the grid, and what would happen in future, what would happen in 2030 when, as Dr. Jainan Vyas said, we would like to bring down the emission to 45%. And by 2070, we would like to become a net zero carbon. So in that case, if you would look at the dynamics of the grid operations, you would really be surprised that, how these grid operators are operating the grid, because renewable is always the priority. But at the same time, looking to the operating challenges, asset integrity also is a very, 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 very prime factor. So we have narrowly related this, described here, the integrity of the boiler component and asset system is often compromised due to the degradation in the material properties by active damage mechanisms. There are total 36 damage mechanisms in the boiler. So know-how about the damage mechanisms, rate of degradation, and failure modes by which operational integrity get hampered. The damage mechanisms are majorly classified as, already mentioned, that thinning damage, cracking damage, external damage, high temperature attack, mechanical damage, brittle damage, high temperature metallurgy degradation. Upon identifying the correct damage mechanism, there are methodology to arrive at associated consequences of the failure due to active damage mechanism. Now, before that, I just stuck up in the mind. Basically, last week, one, meeting was, steering committee meeting was scheduled by CII, Power Summit 2023, in which co-chair of the session, is from very prominent boiler manufacturing industry. And their main, steering committee chair, they have invited TCR Advanced Engineering Private Limited to be a part of that particular steering committee. So in that particular committee, as Mr. Rahul Vidya said that we should now go along with the digitalization and the physicalization. So the same thing was told by our managing director in particular steering committee meeting. And I feel honored to say that, co-chair of the, that particular steering committee, who is very prominent and very, high-ranked management cadre of a very big, power boiler industry. And he validated his statement that now it's a time to rather see that now how we can carry out the audit of the boiler. So I have very briefly, because it's a very big subject and it's a 240 pages, I brought it down to 5 pages. So I won't be able to, I won't be able to satisfy your queries, but let me to say that, we did recently one audit. Of course, actually that boiler was under shutdown, and we were in contact with the client since more than 6 to 8 months, and we were correlating all the process parameters and process data, their dynamics, right? Steam requirement, what is the process requirement? It is a cogeneration. So this is it's written on the screen itself with what is the specification: 200 tons per hour boiler, rated pressure, design pressure, rated steam temperature, feed water inlet temperature, everything is written. Now we found that the tube leakages have been reported on multiple occasions and major damages have been detected in the primary superheated tubes, particularly the leading edge located at the furnace exit and the boiler bank sidewall. So we are mostly rather concentrating on superheated tube because 60% of the total failure was from superheater, and more than 30%, from boiler sidewall banks. So here we would try to rather say about how we did the audit, So economizer, when we reached to the site, the plant or boiler was under shutdown, and mostly all the superheater curb tubes were in cutting condition, kept outside. But then we started, because we were having the database of their process variations and parameters like temperature, pressure, flow, their fuel data, their water chemistry, what fuel they are using. They are using gas plus, natural gas plus off gas. Off gas is the byproduct of the particular plant. So we got all the data from them, and then we started audit in the shutdown boiler. Rather, we have experience of audit during the boiler is in operation, because as I said, we have more than 2,000 failure investigation repository, exhaustive repository of boiler parts only. So we know that which damage mechanism has induced because of what process. And we also know that which are the vulnerable area in the boiler rather to attack, so that we can reduce the inspection locations, inspection intervals, and proactively act on the boiler. So we found that there are few hot spots and hot gas leakages in the boiler, but then we, while auditing, while observing, while doing the survey physically, we found that they have eliminated, or rather they have resolved the issue by changing the refractory in insulations. So in that way, they told us that now there is no problem of this hot gas and hot spot issues. Steam drum and water was also magnetite layer and deterioration also we shared with the client. Now this primary superheater, actually this primary superheater, if we talk about a simple, small brief about design. So the primary superheater is made of 52 tubes in the twin loop, that's 208 eighths, and total 57 tubes leakages have been occurred in primary superheater of all operating 3 boilers. They have 3 boilers. So we rather contacted their design people, and we asked their, or other operating people, or their inspection and efficiency department about what causes you have been found in these particular areas. They said that caustic, stress corrosion, corrosion fatigue, and creep damages. But over and above that particular thing, we rather indicated them that because these tubes only on leading edge have been found defected, so there are also chances of high radiation heat from the furnace, because their installation and design we looked after. We gone through their design and installation network and setup, because I won't be able to do much on this subject. So, but on that basis, we said that high radiation heat from the furnace, especially on the tubes facing the burners at the center of the boiler, and possible water carryover from the drum. That was the very, very important point we noted, and we told them. Secondary superheater, as said, we didn't find any problem rather while auditing the boiler. But referring to the process data, we found that the temperature secondary superheater is in the range of 255 to 260 degrees, close to saturation temperature. So compared to design value, approximately 320 degrees centigrade operating on final superheater with inlet temperature close, the saturation is not recommended. So we just brought to their notice that this is simply not correct, because your design temperature is 320 degrees, and if there is a moisture in the saturation temperature goes to the turbine, then there would be a chances of the erosion and blade failure. So most important point, we found that the drum level, high level and low level drum settings were not correct. Actually, we do not know how they did this, but we told them that this would be the primary cause, because low level of drum setting and will rather impede the operations of the separators, the drum internals, and high level would result into the outlet of the separator steam path and will go to the secondary superator. Even secondary superator also we found that atomerator was continuously operating in operating condition. And their block wall settings were also not proper. I mean, they did that exercise on somehow some manual basis and something. Then we found, combustion control and burner tuning. As such, we found that they are operating boiler with the manual control because we didn't find, oxygen analyzer. O2 analyzer was not there. So they were adjusting the airflow as per the combustion ratio. So then we asked their operating people that how do you rather regulate airflow? They said that normally we keep it at 3%. However, we found that 1.6 to 2.4% at 100% MCR to up to 80% MCR should be there. So, of course, that will naturally rather disturb the flame shape as per the recommendation of OEM. So that also we brought to their line, their mind. This is the book about industry contribution. This is written by, co-authored by Mr. Parashari Bhakti, and in 2018, and published by ASM, and subsequently one more chapter in handbook also was added regarding failure of boiler and related equipments, and that also been published by ASM in 2021. So this is our credentials. Now in short, we would look at how asset integrity can be maintained. We have, as I said, I reiterate again that we have plus 2,000 failure investigations of boiler itself. So, of course, based on the backup, qualification is there, experience is there. So based on the data failure record, TCR have in-depth knowledge to identify the applicable damage mechanisms for the given operating facility. So asset integrity optimization and management implemented across all stages of the asset life cycle. So it can ensure increased efficiency by ensuring asset performance to its intended function and life. So by virtue of that, we rather maintain the reliability. We know that asset integrity optimization management, which can support our endeavor of knowledge-based study, which correctly can be substituted for the import of technology and can complement the Atmanirbhar Bharat and Make in India initiatives by promoting the development and use of locally made technology-driven tool, which can help to boost the domestic technology industries and reduce dependence on the foreign technology and currency. So asset integrity optimization is a software system developed by TCR Advanced Engineering Private Limited, and it is designed to facilitate asset integrity management at plant level and implementation of knowledge-based study at the plant site on continual basis. So, in brief about, I would talk about what is asset integrity and optimization management. It's a software basically, but it's a tool, and it's an analytical tool precisely if I speak about. So, what are the functions and what does it offer? What are the characteristic of this particular software? Is identified critical plant equipment and process conditions, fixed inspection schedules, and based on the risk assessment, maintaining integrity by way of feedback of look, listen, feel, failure analysis, condition monitoring, predictive maintenance, fitness for service (FFS), and as Mr. Rahul Vidya said that in even this brochure also it is written that nowadays this twin technology that person can handle the boiler sitting at house. This is called the twin technology. That's the Internet of Things rather. So our tool comprises of all. Of course, it's not a twin technology tool. So as I said that that we should take RLA as a
Deepakji, please
2 minutes.
conclude.
Please, thank you. Define inspection points area for each equipment for effective data generation. So now these are the few differences of time-based inspection and knowledge-based inspection. Time-based inspection is what we are doing the RLA, and knowledge-based inspection is what. So it is very self-explanatory. How knowledge-based study would help us to rather proactively add on any problems in the boiler. These are certain functions of the our tool. One of the tool is asset analytics. Many tools in the market like SAP, it is prevailing in all the industries, but we are analytical tool. We are not a accounting or database tool. ALM philosophy and its architecture is minimizing the downtime, loss prevention, configurable to any legal compliances, proper documentation for maintenance and inspection. And architecture is based on multiple data inputs. The knowledge of different damage mechanisms for specific material of constructions in given operating condition forms the basis of the prediction of the possibility of damages. So now conclusion is very important. As everybody has said about future scenario or energy scenario in India, we have collected some data from report on optimal generation capacity mix for 29-30 wasn't to published by Central Electricity Authority. That coal-based capacity addition of 16,205 megawatt is required to meet electricity demand requirement in 2029-30. Apart from the coal-based capacity of 26,900 already in construction, which is currently, and again RE capacity also is written about. So in that condition, what would be the situation of grid operator and what would be the situation of power generating industries? So we this study reports rather prompt industries to emphasize on the need of a time to grab the opportunity and implement practice of audits. So I would request high officials from Boiler, Government of Gujarat to rather look in this subject, and I think that would definitely, as even Patel sir, he's a director of Boiler, he said about that they are conducting the trainings at various locations, and he has very rightly said that, our work is not more at the big industry, our work is more at the industry where owner himself is operating the boiler. So that's a very fundamentally very good idea, and I mean, if we jointly think on the direction of digitalization and physicalization in the boiler feed, I think we would achieve our desired target in a safer and environment-friendly manner and maintaining the asset integrity. Thank you very much.
Thank you. I will invite Vipul Paul from Fort Marshall to give his speech for the steam distribution system.